Good afternoon, good evening, or good morning. My name is Steve Kaz. I am a data scientist, and I recently just finished up a final project on predicting player performance value based on podcast transcripts. And it is a player performance value based on Call of Duty. Specifically, the podcast is The Flank. So our problem statement: currently there's a lack of professional Call of Duty analysis, as a lot of the sources are currently unreliable and not easy to interpret when it comes to determining a player's true value, with the most popular site being the Breaking Point, which I'll get into a little bit later. This is used their own measurement of player impact via Slayer rating and BP rating, and then there's been a couple other analysis done via Twitter or X users. Some have gained some respect over the past couple years as Call of Duty keeps on going with the competitive scene, but still could be more transparent in their math. So our data is taken from The Flank. It is a podcast, a Call of Duty podcast that runs every weekend of the Call of Duty season, as long as there are games being played during that week. They typically hold these Thursday, Friday, Saturday, and Sunday, with Saturday and Sunday being like the losers grand finals and the grand finals type of day. The hosts of The Flank include 5 people. You got Octane, Zuma, Ached, Benjay, and Parasite. All of them have which competed in Call of Duty in some shape or form. There are guests that occasionally join in, as you can see in this header that I took from The Flank's Twitter page. You also have Enable, Attach, and Temp, which are also players or past players. Some could also be coaches, which Benjay was a coach. Moving on to the goals. The goal of this project is to develop a model or an approach to predict player performance value from 1 to 10, or on a 1 to 10 scale, from podcast transcripts, compare weighted Ensemble approach against traditional regression models, which we'll see is a drastic difference. Determine if podcast sentiment alone is sufficient for performance prediction. The main research question is, can podcast transcripts predict player performance in the CDL? How well can they do it? So about the CDL. The CDL composes of 12 teams that compete through a 7-month season from December to July. The season structure is that they play qualifiers. These qualifiers can be from 7 to 10 games, which determines their seeding or tournament placement in the upcoming minor or major. Minors are typically your low earning, where you're earning a good amount of change, but you're also getting not the most. Like, typically winners walk away with around 20,000, split amongst 5 or 6 players. And then they also get CDL points, which I'll get into later, with their minor, with the first place getting around 30, in comparison to majors, where you could win up to 200 grand and get around 150 to 200 CDL points, depending on how many games you play. And then ultimately, these CDL points are counted up, with the top 8 going to the championship, the CDL championship, where players compete for a giant cash prize as well as a ring, similar to a Super Bowl ring. Then, as mentioned, player performance can vary depending on matches and tournament placements. So let's say you go 0 and 7, or maybe 3 and 4, and you barely make the cut to get into the major. You will be starting in the lower bracket. My apologies. 3 and 4. If you go 3 and 4 out of a 7-game series, you're probably going to start in the upper bracket. So you'll probably be like the 7 or the 8 seed. Whereas if you went like 2 and 5 or 1 and 6, you'll most likely start in the lower bracket. Meaning that if you start in the lower bracket, you lose one, you're out. If you're in the winner bracket, you lose one, you play again. Then you lose another one, then you're out. And this can vary depending on who they play, how badly are they outmatched or out-strategized, and so on. So the performance value definition that I will be using, it's a weight composite from Breaking Point stats. So the performance is KD The KD ratio scaled times 0.5, so it has a 50% weight. Damage scaled times 0.3. Hill time scaled times 0.2. Then scaled to a 1 to 10 normalization. 50% KD is the core slaying ability, 30% damage, engagement, and pressure, 20% hill time objective contribution. The results of this was I got a mean of 5.92 for performance value, a median of 6.09, and the range was about 2.6 to 8.03, which is really good compared to my last results. It is also worth mentioning that I do not take into account the other two game modes. This is strictly just hardpoint and KD and damage factors. So for my EDA, I wanted to explore a little bit. So I did performance value distribution, approximately normal. I did a KD ratio from top and bottom players. I believe the bottom players are not shown directly, but I do have a chart that I could show you within my report. Damage versus hill time by role, I do show that. The feature correlations, and then the outliers. Using histogram, scatter plots, heat maps, and box plots. So this is the performance distribution. In the top left, we have the distribution of all 59 players. And then in the top right, you have it box plotted by performance value for position, as there are two positions. Technically, there's three, but it's easier to put it into two, because if you put it into third, it could have some multi-collinearity. So there's AR, SMG, and then there's Flex. Flex is typically someone who plays AR and SMG depending on the map. So we just kept it to the two categories. And then for performance value, you can see that SMG is ranked really high, or has a high density in the 4 to 6 range, whereas AR kind of has a more normal distribution, but skewed a little bit to the right towards the 5.5 to about 7.5 range. Here we're going to our KD deep dive. This is our distribution of just kill death ratios across the board. As you can see in the top right, we have the top 10 players by KD, with Rencor having the highest, and then the bottom 10 players by KD, which would be Beans. Keep in mind that players do get dropped or picked up whenever a major typically ends, as teams want to make the best performance and optimize their team the best way possible. And then we have the KD ratio by position. This is then again split into the AR SMG. We have the distribution of KD ratios, with the mean being a 0.98, which isn't too bad, as typically a 0.9 KD is pretty solid. So now we're getting into more of the AR versus SMG difference. So on the left, the key performance indicators, obviously we have the HP damage per 10 minutes and the HP time per 10 minutes. Those are mainly the hardpoint stats that take into that weighting, as they take about 30% and 50%, no, 30 and 20% into the performance value. For KD distribution, we have the density chart that we had previously, but this is just for KD by position, and we could see that it's skewed a little bit to the right as well again. And then we got the performance value spread by position, with there being a lot of players within the AR around the 6 to 8 range, with SMG having more closer to that 6 range. Here is the damage versus hill time. We had hardpoint damage distribution, objective hill time distribution. Then we got damage versus objective time by role. It is typically known that the ARs will be on the hill more often, just because they could just sit in one spot and hold it, whereas SMGs are kind of the get in your face and let's go at them type of role. And then in the bottom right, we have the Slayer rating, which is the rating that Breaking Point uses. And then we also have our computed performance based on their Slayer rating. Now we got the outliers. KD ratio distribution with outliers. Like I said, players could get dropped or removed from the team at any point during the season. So if they only play 2 games, that could cause some bias or some outliers if they did really good or really bad. For instance, on our KD ratio versus performance value, we have Legend who played 2 games and then got dropped into the Challengers, which is like the tier 2 seed, as the team was trying to look in a different direction. So the key EDA findings I found were the performance distribution was approximately normal. The performance KD correlation was 0.89, which was strong. AR versus SMG difference. AR was a 5.98, SMG was a 5.50. Damage versus hill time. It was mainly independent, which was good to see. The outliers, we had 3 elite players, and we also had the 1 bad player, but we can't say that he played bad just because of his lack of games played. AR players are more predictable than SMG players is what we got from this. So some feature engineering. We extracted 7 features per player for each episode. Our data set consisted of 40 episodes. These are the features listed. This is the description. The features tested 5 regression models and then our Ensemble. So the 5 regression models are my previous attempt earlier that was made in the proposal, and then the Ensemble is what I'm making, or what I made currently. The training testing split was 75% training, which was episodes 1 through 30, and then 25% training testing, episodes 31 to 40. Why the podcast features failed. So ultimately, with my 5 models that I tried earlier, I also did try Lasso, and it gave me the same thing as Ridge. I just didn't include it here, as it just seemed redundant with having 3 models exactly the same. So podcast only regression models performed worse than even guessing the mean. As we could see, there's a negative variance explanation in our R squared. And then our mean absolute error was way too high. Typically, we want to be less than like 0.3 or 0.2. The goal is to be 0, but we'll see. The reason why these failed, though, was it was narrative over numbers. There could be podcaster bias. There's sarcasm and context missing, which was a limitation with my library text blob. There was limited player coverage, as only 34 of 59 players mentioned. And then there was a weak predictive signal alone. It is worth mentioning that these graphs were made in my final approach when doing my weighted assemble, as I was able to clean my data a lot more efficiently and not run into as many errors. So the solution, weighted assemble. Instead of relying only on podcasts, we combine multiple signals, player historical average from training episodes, player clusters, similar performance profiles, position average, AR versus SMG, and the result improved from 1.14 to a 0.376. So how it works, the assemble weighting, was for players with history, it would do 70% history, 20% cluster, and then 10% position. For players without history, it would be 50%, 30%, and then 20% global instead of the history category. The clustering was a K-means with 5 clusters on KD damage and hill time. The position average, AR equal to 6.2 and SMG equal to 5.7, with the global average being about 5.92, which is pretty fair, as I would like to say that most players aren't completely terrible and could at least be mediocre. With my weighted assemble approach, I was able to achieve the following performances. My MAE, as mentioned, was 0.376. R squared was 0.773. CCC was 0.848. CCC is something that I've been wanting to try for a little bit, and I'm glad I was able to actually fit it in here, as I think it's a better sign of R squared. And then I also included RMSE, which was 0.664. Bias was basically 0, which I was really happy with. And then accuracy, plus or minus 0.5, had an accuracy of 78%, 4 fits within half point. And then accuracy plus or minus 1 had 92.5%, which was really good. There was 11.3% improvement over player historical average baseline. So predictions by player role. AR was a lot more easier to predict than SMG, as SMGs kind of vary based on role variation, whereas AR was typically an anchor rifle playstyle. The top 10 predictions with their errors. So, as we could see, ARs just dominated the predictions, or the top 10, with only Simp, which is our most recent major winner for Major 3, just one. So he should be ranked pretty highly, with Mercules and Dashi coming in second. Moving on, our feature important, what actually mattered from the podcast. So this is a breakdown of our feature engineered elements. Sentiment standard deviation, the volatility had a 40.2%, sentiment mean had a 26.5%. And then average sentence length was interesting, as it also had a 21.5%. So I thought that was really cool. So comparison to breaking point. So Slayer rating converted to a 1 minus 10 or 1 to 10 scale. It is used or converted with the equation 1 plus Slayer rating times 9 divided by 99. And then Slayer rating versus our performance value. The similarities, well, they both measured player impact in one way or another. The difference was that Slayer rating weighs kills more heavily, which makes sense. And our performance value includes objective play, which I think is very important, as that is typically not captured when analysts do their analysis. The Slayer rating also uses a different formula per game mode. Our model predicts based on podcast discussion, not recalculating stats. So the key findings, podcast features alone cannot predict performance. Weighted Ensemble succeeded. Volatility matters more than average sentiment, and AR players are more predictable than SMG players, with the following that I described earlier. So the limitations, because I only did 40 episodes, which ranged from Major 1 qualifiers to Major 3 qualifiers, there was only 59 players, but not all 59 players were mentioned. There was only 34, as we can see in player coverage. There's podcaster bias, there's text blob limitations. There was, because I'm using YouTube podcasts, there was automatic captions, which could have errors within itself. And then seasonal effects, patch changes not captured as well, as it wasn't clearly shown what SMGs were becoming meta, what maps were becoming meta, and meta being like very popular or the go-to in order to get the best success. So future work, use LLM based sentiment, GPT-4 or 5 instead of text blob. We could try 4 or 5. Collect multi-seasonal data. So this would just be getting more episodes, or I could include different games as well. Add temporal features, separate models by role, and then real-time deployment. So to conclude, to bring back our research question, can podcast transcripts predict player performance in the CDL? The answer is no, for only using podcast sentiment, but yes when using the weighted Ensemble. Final verdict, podcast sentiment alone cannot accurately. However, weighted Ensemble can achieve excellent results with an MAE of 0.376. The hybrid approach works. The podcast only did not. And here are my references. Thank you for listening. I'm just going to go quickly through my final report that's also linked in this folder for my portfolio. It's going to be under predicting CDL player performance value. This is my paper that I recently just finished up, and I am pretty happy with it. Comparing it to other sources, I have done something that nobody's attempted to do with Call of Duty, or even attempted to do for podcast transcripts. Sorry. But yeah, feel free to read through this as well. I'm not going to go too in depth of it, but I appreciate everybody for listening, and hope y'all have a good rest of your day. My name is Steve Kaz, and I'll see you guys in the next demonstration. Thank you. Have a good one.